Alright, in this video we are going to find the possible zeros of this function. Not the actual zeros, but the possible zeros according to the rational zero theorem. Then we're going to factor it completely and write it in factored form. And then we will find the actual zeros of the function. So first of all, when we talk about finding the possible zeros, and you see this key word, possible, that automatically means you're talking about the rational zero theorem or the rational root theorem. And that's the one where we learn to build a list of possible rational zeros by looking at possible numerators and denominators. And we have learned that the possible numerators are always going to come from the constant term on the end. All right, so and when I say come from, I mean factors of. So the factors of 5 are 1 and 5. So those are the possible numerators. The possible denominators are going to come from the leading coefficient, factors of 5. So this was a relatively easy problem because one of the most common mistakes is mixing up which number gives you numerators and which number gives you denominators. But in this case, they were the same number. So even if you had it backwards, it still would turn out okay. So you're welcome. But now we need to make the list by mixing and matching these numerators with these denominators. I encourage you to take one denominator at a time. So if I do a denominator of 1, I've got 1 over 1 and 5 over 1. Okay, so 1 over 1 is 1, 5 over 1 is 5. Then I will look at having a denominator of 5. That's 1 over 5 and 5 over 5. 1 over 5, of course, is 1/5. 5 over 5 would be 1, but we already have that, so do not write it again. And then all of these can be positive or negative. So that is the list of possible zeros. Notice these are not the actual zeros of the function. There are 6 of these, including the pluses and minuses. But we know there are only 3 actual zeros because of the degree. So it's a matter of which of these 6 are the actual zeros, and will there be any imaginary zeros which wouldn't be on this list. Okay, now let's go for a factored form. Now if we had to guess, we could start trying these numbers in synthetic division and until we found one that gave us no remainder. However, no one told us that we were not allowed to use a calculator, so I am not going to guess. I'm going to use the calculator. Okay, so the way you use the calculator is you go to your table feature and you type it in. So we have 5x to the third power. Whoops, that was a fail. Okay, 5x to the third power minus 31x squared plus 31x minus 5. Alright, I always start at negative 10 because it rarely goes past that. Just leave it in auto. So I'm just going to scroll down looking for 0 on the y side. Okay, so I found 0 right here. 0 is at the number 1. So that means the number 1 is definitely one of our zeros. So I'm definitely going to have the number 1 as one of my zeros, and as far as factored form, I'm definitely going to have x minus 1. But now I will use synthetic division to factor completely. So if I do my synthetic division, okay, using the number 1, so I have 5, negative 31, positive 31, and negative 5. Alright, I should get a 0 remainder. Okay, 5 times 1 is 5. Alright, that's going to make, what, negative 26. Negative 26 times 1 is negative 26. That's going to make 5. 5 times 1 is 5. And of course, I get the 0 remainder. Now, I need to take this trinomial and turn it back. Well, I need to take these three numbers and turn them into a trinomial. So this would be 5x squared minus 26x plus 5. Now I'm going to try to factor this. If this does not factor, I will use the quadratic formula. So 5x squared can only factor as 5x times x. 5 has to be 1 times 5. Now I'm not going to put the 5 here because that would make a common factor, which you should never have a common factor inside the parentheses. So I will go straight to this, 1 and 5. Now I know inner plus outer equals middle. Inner, I have 1x. Outer, I have 25x. I'm shooting for a middle of negative 26. So if both of these are negative, that'll give you negative 26. So that means both of these would need to be negative. And negative 1 times negative 5 is positive 5. So I know I have factored it correctly. So in addition to the x minus 1 that I had right from the beginning, I now have these two additional factors of 5x minus 1 and x minus 5. If I set these equal to 0 and solve, okay, for example, if I set 5x minus 1 equal to 0, alright, that's going to give me 5x equals 1 and x equals 1/5. And of course I get x equals 5 from this one. So there it is. We have factored completely and we have found the actual zeros. And again, we knew there would be 3 zeros, not 6. Those were the possible zeros. These are the actual 3 zeros. And that's it for this problem. Alright, the next two problems are very similar, so I'm just going to keep going with the same video. Okay, so number 2, again, just like on the previous problem, we're looking for factored form and we're trying to find all the zeros of the function. Now, what I could do is I could type this function into my calculator just like I did on the previous problem and scroll down and look for 0 in the calculator. I don't need to do that because I can see 2 out of 3 of the roots of the function right off the graph are pretty clear. But if for any reason you were having trouble reading the graph, you could just type the function into your calculator and scroll down and find those zeros. And maybe I'll look at that in a minute. But I can see that this has an x-intercept of -3 for sure, and an x-intercept of +3. Now this one right here, that's in between the lines, so I don't know exactly what that is, but you know, -3 and +3, that's a guarantee. So I will start with my -3. You know what, maybe I'll just show you on the calculator as well real quick. So imagine I were to take this and type it into the calculator. Okay, I typed it in. Alright, so I'm scrolling down. And oh look, there's a 0 at -3, and then that's the same -3 that I'm seeing on the graph. The graph is also showing a 0 at +3, So notice if I keep scrolling down to positive 3, oh look, there's another 0 at positive 3. Okay, so I'll be watching for that positive 3 to show up in a minute. So whether or not you use the calculator or the graph, you see the negative 3 showing up. So if I have a 0 of negative 3, that means I have a factor of x plus 3. So let's go ahead and do synthetic division at this point. So I have negative 3, and I've got my 2 minus 3, and my negative 18 plus 27. I'm betting we could have done grouping with this, but I'm not going to worry about that right now. I'm just going to keep on going with my synthetic. Okay, so if I bring this down, that's 2. 2 times negative 3 is negative 6. That makes negative 9. Negative 9 times negative 3 is positive 27. Negative 18 and 27 make positive 9. And 9 times negative 3 make negative 27. And we get that 0 remainder. Turning this back into a polynomial, this would be the constant, this would be the x term, and this would be the x squared term. So I have 2x squared minus 9x plus 9. So now I'm going to try to factor this. Now we already saw that x plus 3 is one of the, we saw that 3 is one of the zeros, which means if 3 is one of the zeros, that means x minus 3 is going to be one of the factors. So you can bet that x minus 3 is going to be one of the factors here. So if you sort of keep that in mind, it makes it easier to factor things because you know it's going to be 3. But anyway, so 2x squared can only be, I'll just do it like I normally would. 2x squared can only be 2x times x. 9 could be 9 times 1, but I'm betting on 3 times 3. And what do you want to bet? This is going to wind up being x minus 3 right here. But inner plus outer equals middle. Inner, I have 3x. Outer, I have 6x. I'm trying to get negative 9. So I need both of these to be negative. So minus and minus. So there's the x minus 3 we were predicting. So we have our other factors. We have 2x minus 3, and we have x minus 3. If we set these equal to 0 and solve, that's going to give us 3 over 2 and positive 3. Okay, and you know what I'm saying that, but what I'm doing is I'm taking 2x minus 3, because some students will make a mistake on this. I'm setting that equal to 0, and I'm solving. So if I add 3 to both sides, that's 2x equals 3. If I divide both sides by 2, that's x equals 3 over 2. So that's where this is coming from. Similarly, setting this equal to 0, you get 3. So there it is, factored form, and here are the zeros. So the you see the negative 3 and the positive 3 that you see on the graph. And then there's this one that's in between the lines. That was this 3 over 2. Okay, the next one is very similar, so let's do it on the same video. It's pretty much going to be the same thing. We know, like looking at the graph, I see we have an x-intercept here at negative 5, and we have an x-intercept here at 1. So we know we have these two zeros. We have 1 at negative 5, and we have 1 at positive 1. Right away, that gives me two factors. All right, that's x plus 5 and x minus 1. Now, I see here that this is degree 4. That means there should be 4 zeros. So I need to find the other two zeros. Now, there are no other x-intercepts, so that means the other two zeros must be imaginary. So watch out for that. So putting this into my calculator will not help me find any other zeros because they're imaginary. So what I need to do is go straight to my synthetic division. And because it's degree 4, I'm going to have to do synthetic division twice. So be ready for that. Okay, so let's start with the negative 5. So I've got 1, 4, negative 1, 16, and negative 20. And I'm going to do that synthetic division. So 1 times negative 5 is negative 5. That's negative 1. Negative 1 times negative 5 is positive 5. That's 4. 4 times negative 5 is negative 20. That's negative 4. And negative 4 times negative 5 is positive 20, which is 0. Okay? So at this point, I could either use my other 0 or I could do grouping. I think I'll show you both. Let's see. Let's see how grouping would look. I have 1, negative 1, 4, negative 4. Let me switch over to the black screen. So I had 1, negative 4, and I already forgot what it said. Whoops, 1, negative 1, 4, negative 4. My memory is horrible, people. Okay, if I turn these numbers back into a polynomial, this is the constant, this is the x term, this is the x squared term, and this is the x to the third power term. Okay, so this is what I have as a polynomial. So if I want to do grouping, then what I'm going to do is I'm going to look at these two terms and pull out the common factor. The common factor there is x squared, and that's going to leave behind x minus 1. Now if I do the same thing over here, alright, the GCF is 4, so I'm going to pull out a positive 4, and that's going to leave behind x minus 1. And then these x minus 1s are the same, so I'm going to pull out the x minus 1, and then that's going to leave behind this green stuff, x squared plus 4. Now this cannot be factored anymore, so x minus 1 and x squared plus 4 is what you have. So these are the factors. Now if I set these equal to 0, then I've got x minus 1 equals 0, and that's going to give me x equals 1. And if I set this equal to 0, I've got x squared plus 4 equals 0. This cannot be factored, so I'm just going to have to subtract 4 from both sides and get x squared is equal to negative 4. Now I'm taking the square root of both sides. Alright, don't forget your plus minus. So that's going to give me x is equal to plus or minus. Now that negative tells me when I have a negative under a radical, I will have I. So ignoring that for a moment, the square root of 4 is 2. So that means I will have plus or minus 2i. Now remember, this x minus 1 and x equals 1, we already saw that off the graph. We already have this written down, so we don't need to write this down again. So we'll just keep that and add on the x squared plus 4 factor and the zeros of plus or minus 2i. Okay, so this is the answer. Now, let's say if you didn't notice the whole grouping thing, let me show you how you could have gotten to the same answer by continuing with synthetic division. Let me move this out of the way for a second. Okay, so we did the -5. So, so far, let me just rewind the clock. So, do over. So, I'm starting with my -5. I did my synthetic. I have this. So far, I have this 0 and this factor. But I know we have another 0 of 1 coming. Okay, so what I can do is I can now take this other 0 of 1, okay, and I know that's going to give me the x minus 1, so that's going to come into play now. So I will do synthetic division by putting that 1 right here next to the bottom row of the previous synthetic division. Now if I bring this down, alright, 1 times 1 is 1, that's 0. 0 times 1 is 0, that's 4. 4 times 1 is 4, that's 0. If I put the variables back in, this is the constant, this would have been the x term, and this would be the x squared term. So that gives us x squared plus 4. This doesn't factor, so that's why x squared plus 4 is the remaining factor. And as you saw a minute ago, if you take that and set it equal to 0, take the square root, you get plus or minus 2i. Okay, so that's two different ways you could have solved it. You could have done grouping after doing synthetic division once, or you could have used both of the zeros from your graph, and you could have found it that way. By the way, if somehow you couldn't read the graph, you could have put this function into your calculator and scroll down, and you would have found the -5 and the 1 off your calculator. So you didn't really need the graph. You could have done this whole problem without the graph if you had trouble reading the graph for some reason. Okay, alright, the next problem is completely different, so I think I will stop this video here.